All right, guys, welcome back. We're going to be moving on with our spanning tree discussion. We are in our second to last discussion about spanning tree. We're talking about, last time we talked about the rapid spanning tree protocol, but now we're basically, probably won't take 2 hours. It might even only take about an hour. This is not a really in-depth topic, but from the lab perspective, this could be something that you would see on the lab potentially as options that you would have to configure. We're going to be talking about optional spanning tree features, what some people kind of refer to as what we call the Spanning Tree Toolkit. Let me go ahead and pull up a notepad document, and we will call this the Spanning Tree Toolkit, which includes things like Portfast. It includes BPDU Guard. It includes BPDU Filter, Root Guard, Loop Guard, UplinkFast, BackboneFast. Let me think, what else? Etherchannel Misconfiguration Guard. And I believe that's it. Let's go into our command line real quick and take a look at what that might look like. So let me go over to my command line. And let's see here, show spanning tree, show spanning tree summary. So these are all the features that we're talking about. Etherchannel Misconfiguration Guard, I'll talk about that in a little bit. Portfast, BPDU Guard, BPDU Filter, Loop Guard, UplinkFast, and BackboneFast. So that's really our goal in this lesson, is to kind of go through all of those individual pieces. Some of them we use on a regular basis. Most of them are either automatically configured when you're running spanning tree in rapid mode, or they're just features that you would not necessarily run. Okay. Like I said, it probably won't take too long to go through the discussion, but you know, if you guys have questions or you have any comments, let me know, and I'll be more than happy to kind of get into a little bit more detail. So let's start by kind of defining what each one of these pieces represent. These are the plus options that we talked about, what we call the Cisco enhancements to spanning tree. And basically in this entire lesson, we're going to talk about how to configure Portfast, BPDU Guard, BPDU Filter, UplinkFast, BackboneFast, Loop Guard, and so on. All right. So I'm going to describe what each of these features are, and then we'll kind of demonstrate how to implement those features and maybe how to troubleshoot those features, how to verify their operation, and some of the caveats and considerations that you might have. Portfast. Let's start with that one, because Portfast is a feature that we use all the time. All right. Let me go ahead and jump over here to my notes. So Portfast, that'll be the first option that we talk about. And Portfast is a feature that you can enable to essentially bypass the STA process on host ports. Okay. Or it could be trunk ports as well, depending on what kind of trunk port that might be. All right. So we're going to take a look at why we would use Portfast. What are some of the caveats to using Portfast? How we can implement Portfast both globally, and how we can implement Portfast on a per interface basis, and where we might apply those concepts as part of our configuration process. Okay. Something you guys are probably already well familiar with. Portfast causes essentially a switch or a trunk port, if you have it configured on a trunk port, to enter the spanning tree forwarding state immediately, bypassing either the learning state or the listening and learning state, depending on what it is that you have configured for spanning tree. We can actually configure Portfast on a trunk port, but we would want to make sure that that's a trunk port that still goes to a single workstation or a server or maybe a router on a stick or something like that to get that port to operate or move into a forwarding state immediately. You can use Portfast to connect a single end station, or you can use it actually on a switch port. But if you enable Portfast on a port that's connected to another layer 2 device, there could be the potential of creating a loop in the topology, at least a temporary loop. All right? Basically, the way that it works is that when the switch powers up, or when a device gets connected to the port, we start to go through those processes that we looked at in the last session about the different states, right? And in 802.1d, that includes a listening state, and then a learning state. So we've got these forwarding delay timers that have to expire before we can actually move into a true forwarding state. As those delay timers expire, the port transitions from a forwarding state to a forwarding state or a blocking state, depending on what we decided was appropriate for that particular port. All right. So when we enable Portfast on a switch port or a trunk port, the port immediately transitions into that forwarding state. Portfast does not disable the spanning tree process on a port, though. A Portfast port will actually move back into a regular spanning tree process, and it'll become a normal spanning tree port if, in fact, it receives a BPDU on that particular interface. All right. Now, we typically will use Portfast in combination with another feature, which is BPDU Guard. But before I get into that, let me just demonstrate a couple of concepts about the Portfast feature. And it's really simple, right? You can choose to enable this globally, or you can choose to enable this on a per interface basis. So let me do a quick show interface trunk because I believe, I'm going to go ahead and convert my interfaces back to .1Q interfaces, just because we want to make sure we get normal operation with these ports here. And we'll just do a switch port trunk encapsulation .1Q and switch port mode trunk. All right. Now, if I do a show spanning tree summary, I can see which features are enabled and disabled on the interfaces, or on the, as far as the Spanning Tree Toolkit goes, which features are enabled or disabled on the system. And we can identify here that Portfast is disabled by default. Now, if I do a show spanning tree and a question mark, there really aren't any options to kind of look at a Portfast specific information, but we'll take a look at some of the details a little bit later on. So if I do a detail, for example, I can see specifics about a port, how many ports, how many BPDUs I've received and sent, and I would be able to identify whether or not the port is running specific features. To enable Portfast on a global level, we use the Spanning Tree Portfast default command. Notice there's no options with this command. It's just basically saying, I want to go ahead and enable Portfast on all of the interfaces on this switch. It will enable Portfast on all of the interfaces on the switch as long as those interfaces are not trunks. And that's the key. So when you're using the default option, Portfast is enabled on the switch. Spanning tree summary. You can see now that Portfast default is enabled. If I do a show spanning tree detail, let me see if I can actually pull out. No, I can't really pull out an interface. We don't really see any indication that Portfast is necessarily enabled or disabled. Let me see if I can pull up a port that's not actually connected to another switch. Yes, here we go. That's what I was looking for. So you'll notice that the interfaces that are identified as trunks, which would be like 1.1 and 1.2 in this particular case, there is no designation of Portfast on those ports. But if I scroll down here, and I can see that port 2.2, because it's not a trunk, is in the Portfast mode by default. So it automatically enabled the Portfast features on those ports. Let me see if I can do another show spanning tree output interface Ethernet 2.2. Yeah, that didn't really give me a lot of information. I was hoping that it would also indicate whether or not this port would be working in a Portfast mode or not. But it doesn't matter because the detail obviously demonstrated that concept. All right. Now, some other features like root guard and BackboneFast, we're going to be able to identify whether or not those ports are operating in that particular mode related to those technologies using some different commands. All right, so if I do a show interface trunk, by default, these ports that are acting as trunks are not going to be in the Portfast mode. What would be the potential risk to enabling Portfast in default mode in global configuration? Well, the potential risk is if you have a hub connected to a network, or if you have a switch that maybe is running BPDU filters, so it's not sending BPDUs, you could potentially cause a temporary loop, or actually a permanent loop, depending on what's attached to that hub, in the network, which could be severely detrimental. I would say it's still a best practice, though, to run the Portfast default command, because you're not going to have hubs and those types of devices running BPDU filter and so on in your network. So you don't usually have to worry about that too much. All right. Now, unfortunately, because the interfaces, trunk interfaces, well, it's by design, right? Trunk interfaces are usually connected to other switches. So normally we would see BPDUs on those types of interfaces. But unfortunately, because we've enabled this feature in global mode using the default option, those trunk interfaces are not going to be running Portfast. Let's say, for example, in our topology here, I had a router connected to this switch here. So if I had a 7200 series router or whatever, I mean, I don't even have to really put it in. Let's just assume that we have a router connected to switch 1, and let's say that that router is on port 3-something. Let me do a quick show IP interface brief. So let's say that we have a router on 3.0, okay? So if I go in config T and interface Ethernet 3.0, normally I would configure this with some sort of trunk encapsulation, encapsulation.1q, and I might set it up as a trunk, all right? And that's because maybe my router's running router on a stick, or maybe this is an interface that goes to a VMware server, which has a virtual switch, and we're doing frame tagging on the VMware server that goes to this particular interface. Now, I'm not going to receive any BPDUs on the port, but because it's configured as a trunk and we're using the Portfast default command, that means that essentially the Portfast feature is going to be disabled on this particular interface. So you can execute the command spanning tree Portfast, and we have the option to specify trunk. So that means that we're going to hard configure Portfast on this interface, even though it's acting as a trunk, so that the Portfast feature is enabled. Obviously, you want to be pretty careful with that one as well, because you don't want to hard code an interface to be a Portfast port if it's potentially going to be connected to some device that would cause a loop in the topology. Okay? Now, that being said, what's the best option? I still think that the best option is to enable Portfast on the switch globally, and then enable Portfast explicitly on different interfaces if it's necessary, based on the fact that it's a trunk. So if I do again a show spanning tree detail, and if I go down to port 3.0, I can see that this port is in the Portfast mode based on the Portfast trunk configuration. So you could grep that. You could say, okay, show spanning tree detail, include Portfast. And you could see maybe potentially how many interfaces are operating in Portfast mode based on that. Of course, it doesn't give you the actual information about the interface, so you might have to go and do a little bit of an investigation on that. It's not a bad thing to run Portfast. Once a Portfast port receives a BPDU, however, it loses its Portfast state. And that's when you get that warning. When you enable Portfast on an interface, it says, warning, Portfast should only be enabled on ports connected to a single host, connecting hubs, concentrators, switches, bridges, blah, blah, blah. That could potentially cause a problem, right? Cause a bridging loop or something like that. Okay? Any questions about the Portfast feature? It's not really a security feature. It's more of an enhancement to operations to allow ports to activate more efficiently and more quickly. Now, we might add a secondary feature to Portfast, which is the BPDU Guard feature. I put these two, actually I probably should, well, I'll leave that one down there. These two are the most common elements that we configure for providing a spanning tree security architecture. To prevent loops from occurring in the network, the Portfast is only really supported, as I showed you guys, on non-trunking access ports, because those ports typically are not going to transmit or receive BPDUs. The most secure implementation of Portfast, though, is to enable it only on the ports that connect to end stations. Because Portfast can be enabled on non-trunking ports that could potentially connect to switches, you could still have spanning tree loops. What I mean to say by that is the only reason that the Portfast default command is not going to be enabled is because we're recognizing that we're running a trunk between two different switches. But if I have a switch here and I have a switch here, there's nothing that says I can't connect those two switches with an access port. And obviously in this particular case, that means that we're going to potentially have an issue with a loop in that these switches, could create a loop even if it's in just a single VLAN. Because Portfast would automatically be enabled on these non-trunking ports, BPDU Guard is going to prevent those loops by moving all of the non-trunking ports into an error-disabled state when they get a BPDU on that particular port. So when we enable BPDU Guard on the switch, Spanning Tree actually shuts down any Portfast configured interface that gets a BPDU instead of putting them into the Spanning Tree blocking state, because the amount of time that it takes to shut down a port as opposed to putting it into a blocking state and then going through the election process is significantly faster. All right? If it's a valid configuration, any of your Portfast enabled ports are obviously not going to be receiving any BPDUs. If you have a Portfast port configured on an interface that receives a BPDU, that constitutes an invalid configuration because Portfast is not supposed to be, or BPDUs are not supposed to be received on a Portfast port. So the BPDU Guard policy provides just another layer of security against a misconfiguration or an invalid configuration. All right. Now, there's two ways to implement BPDU Guard. One method is to implement it globally in conjunction with the Portfast feature. The syntax will show us that. So if I do config t spanning tree BPDU Guard, spanning tree, why isn't it letting me type it? That's strange. Portfast, sorry. BPDU Guard, I was thinking about that for a second. I'm like, wait a minute, why am I not seeing that? So Spanning Tree Portfast, and I just said that actually, right? I said enabling BPDU Guard as a sub-feature of Portfast. And it's default at the end there, yep. All right, so by enabling Spanning Tree Portfast BPDU Guard default, essentially what we've done now is we've created a scenario where the BPDU Guard feature is running on any Portfast enabled port. And as soon as those Portfast enabled ports get a BPDU, instead of just simply reverting back to a normal spanning tree process, we're actually going to disable the port, disable the port based on the fact that it received a BPDU. So if I come back into my topology here, and I connect, let's do 3.3, 3.3 over here, over to 3.3 over here, we will notice in our configuration here, actually, you know what? Let me, because remember DTP is running on these interfaces by default, so it's already automatically negotiating it to be a trunk. So let me go into interface Ethernet 3.3, and I'm going to just do switch port mode access. All right. Now I should get some sort of indication that the port is has been violated because it's an access port and we received a BPDU. Let's look at our topology here. Still green. All right. Let me do a show interface Ethernet 3/3. Oops. Show interface. It's still connected. Let me show run interface Ethernet 3/3. Switch port mode access. All right, so let me do this, kind of trigger another event. Let me go ahead and just disable that or delete that cable. And reconnect it. Now what I should see in this case is that the port should error disable if it receives a BPDU. And we may be seeing a timing issue here. In other words, remember when a Portfast enabled port receives a BPDU, it loses its Portfast status, which means it also loses the BPDU Guard configuration as well. So it could be just a sequence of events that are occurring that are allowing this interface to remain active. Let's go ahead and check something real quick. So I'm going to do a quick, what happened to my command line? There it is. I'm going to do a quick show interface Ethernet 3.3. Show interface. Oh my gosh. Show interface Ethernet 3/3. So the port is still active. Let me do a show spanning tree detail. What I'm expecting to see here, begin 3/3. What I'm expecting to see here is that, well, that's very interesting. The port is in Portfast mode, and BPDU Guard is enabled by default. So why am I not getting an event that would cause this port to fail? Let's check switch 2. Maybe that port is shut down on switch 2. Well, it can't be. It's up. Yeah, it's show interface Ethernet 3/3. Connected. Interesting. Show interface trunk. Switch port mode access. I should definitely be receiving BPDUs on that interface because it is part of the topology. Let me do one more thing. Show spanning tree VLAN 1. Let's see if 3.3, it's in a forwarding state on that side. And if I do a show spanning tree VLAN 1 here, it's in a blocking state. So blocking ports receive BPDUs, but they don't send to BPDUs. So most likely, in order for me to trigger an event, I'm going to have to shut down the port and bring it back up, because immediately it should start sending BPDUs. And then I should see on this side, unless rapid spanning tree is just too fast for me, I should see the port error disable. Yeah, still in a blocking state. Let me see, what can I do to force this to happen? I'll tell you what. Let's do a I'll tell you what, I'll just do it on this side. Because the other side is in a forwarding state, it is going to be sending BPDUs. And I'm trying to simulate the process, or actually activate the process of where the port will actually shut down or error disable based on the fact that it's receiving BPDUs. Now, because the other side is already active, it's in a forwarding state, if I come in here and I say Spanning Tree Portfast default, and I say Spanning Tree Portfast BPDU Guard default, then hopefully we will see something occur. What the heck, man? Show spanning tree detail begin 3/3. So it's definitely lost its Portfast state. It's definitely lost its Portfast state, but it's still in a blocking mode. Try one more thing. Trying to get something to fail just to show you what happens. Kind of a challenge. We'll try and shut it down one more time. I'll wait for the status to go down, and then we'll bring it back up. Finally. Okay. So, we finally got to see that the interface has reacted to this BPDU Guard feature. So it says here, Spanning Tree 2, that's a syslog informational message. Well, it's not informational, it's actually an error message. We received a BPDU on port 3/3 with BPDU Guard enabled. I'm going to go ahead and disable the port. And the port moves into an error disabled state because we have that BPDU Guard feature turned on in that interface. Now the only way to actually recover from this would be to fix the loop, you know, that would have caused the problem in the first place. And then to shut the port down and bring the port back up once we've assumed we fixed the problem. So there's another way to actually handle this process, and it's called error disable recovery cause. In a global configuration mode, I can type in error disable recovery, and I can specify the cause, and you can see that these are all possible reasons why a port might decide to error disable. And obviously in this particular case, we're looking for BPDU Guard, right? So we're saying, okay, if a port error disables itself because of a BPDU Guard issue, I want to go ahead and allow that port to recover itself. And what will happen is the port, based on a specific amount of time, will actually try to recover itself. Let me go ahead and change that time to it's a relatively long time. So I want to change that interval to 30 seconds. Okay. And let's see, what should happen is the port should try to reactivate itself within a 30-second window, and the port will start to flap, because as soon as it reactivates itself, it's going to get a BPDU. It's going to identify that there's we have Portfast enabled on the port and BPDU Guard. So the port will then again error disable after it's identified the receipt of another BPDU. All right, it's probably been close to 30 seconds. We may see it on the other side as well. Now, when we do an error disable recovery check, we typically try to check against real time, right? So if I'm getting BPDUs, I'm not going to recover the interface until I know that we're not going to be receiving any more BPDUs. So if I come into this switch and I go into interface Ethernet 3/3 and I shut it down, now we're not going to be receiving any additional BPDUs, so the port should recover itself. All right? So as a best practice standard, you want to enable the BPDU Portfast default command to enable fast transition to the forwarding state for your edge ports, or potentially any trunk port that might go to a physical device that requires a trunking configuration. All right? We should see some recovery here. Let's see, do show. It's not cooperating tonight. Do show interface Ethernet. It's still in the error disabled state. Get out of config mode. Show. So if I use the command show error disable recovery, I can identify what error disable recovery mechanism is turned on. And you know what? I know why it's not recovering. It didn't take my, why is it saying that I have 150 seconds left? The timer interval is set to 30 seconds, but it's saying it still has 150 seconds left. So that's probably why it didn't recover in the first place. But I'm curious why. Let me try one more thing. Config T, error disable recovery interval 30. Yeah, that's all that I get. Recovery. Yeah, I'm not sure why this must be a GNS3 bug, because it should be taking my error recovery timer interval at 30 seconds, and it should be recovering within a 30-second window. But we don't have long to wait. We won't. We'll just let that kind of run. All right. Now another feature that I want to talk to you about that's part of the Spanning Tree Toolkit is Portfast with BPDU filtering. It's not generally recommended to run BPDU filtering because what BPDU filtering does is it allows you to avoid the transmissions of BPDUs either explicitly on an interface, or if you have it configured in conjunction with the Portfast feature. Checking my timer one more time. 45 seconds, okay. Actually, one of the things I wanted to mention prior to moving into that was we looked at how we enable BPDU Guard globally on the switch in association or in conjunction with Portfast. But you might have interfaces in your topology that you're not running Portfast on. Does that mean simply that I cannot run Portfast on those particular interfaces? So let's say I go into config mode, interface Ethernet 3/2. If I say Spanning Tree BPDU Guard, enable, that enables the BPDU Guard feature on that interface explicitly. It doesn't have to be a Portfast port to be enabled. It's actually explicitly enabled. There we go. Attempting to recover from BPDU Guard, error disabled state on 3/3. Okay? So that's the second of the multiple tools that we have in our toolkit. The next one that we're going to look at is BPDU Filter. And like I said, it's something we typically try to avoid using. Most definitely, guys, I saw this on my lab. They're going to have you configure Portfast and some of the basic spanning tree protection mechanisms, like BPDU Guard, like Root Guard, like Portfast. So you definitely need to be familiar with those tools. Okay? As I mentioned previously, filtering allows us to avoid transmitting BPDUs on any Portfast enabled port unless it's exclusively configured on the interface, which means that it doesn't matter if it's a Portfast enabled port. When we enable Portfast on the switch, Spanning Tree places ports in the forwarding state immediately. We talked about that previously. By default, Spanning Tree is also going to send BPDUs from all of the ports, regardless of whether or not Portfast is enabled or not. So we can configure BPDU filtering, which generally isn't recommended, but we can configure BPDU filtering on interfaces if they're Portfast enabled ports, meaning that we want to go ahead and block the transmission of BPDUs on those interfaces. Now you might consider that to be a potential security enhancement. And if it's enabled the correct way, meaning it's enabled globally with the Portfast feature, then the effective result is that we're going to suppress BPDUs from going out of interfaces that have clients connected to them, which is a good thing. We don't want hosts to be able to sniff our BPDU traffic because they can infer lots of information about the topology based on that. So there's two ways to implement BPDU filter. It's generally recommended that you enable it as part of the Portfast feature. So we'll go back into global command, global config, Spanning Tree Portfast BPDU filter default. Okay. So what's happening now on all of the ports that are operating in Portfast mode, we are suppressing BPDUs from going out of those interfaces, which means now we're protecting against interference or possibly some sort of issue with clients capturing a spanning tree information and then placing a rogue server in the network, or even executing some commands on the local machine to hijack the BPDU or the spanning tree process. All right, we can also enable BPDU filter directly on an interface. So I'm going to do that on interface Ethernet 3/2, spanning tree, BPDU filter. I think that's enable. So I've exclusively configured the BPDU filter option on this interface. Now, there is a very important distinction here. When you exclusively enable these features on the interface, they do not disable themselves if they receive a BPDU, because they're explicitly enabled on the interface. If you enable it in global mode, with the intent that we're going to run this on any port that is deemed a Portfast port, then you're certainly much more protected. Okay? Recording. So these are probably features that you're definitely used to using in your own environment, and there's certainly best practice standards using Portfast and BPDU Guard. I would say that BPDU filter should probably be avoided. Cisco also recommends that you avoid the use of BPDU filter unless you have a very specific reason. It's not necessarily a bad thing that BPDUs go to clients, because the whole point is that if a client disconnects themselves from a port and they accidentally plug in a hub or they create a loop in the network, if you have BPDU filter enabled on that interface and it still acts as a Portfast port, it could cause a loop in your topology. Now, the only thing that I might suggest, and this is about the only use case scenario for BPDU filter, is if you have some sort of connection that goes to a different spanning tree domain. So you don't want any cross-contamination of spanning tree information from one spanning tree domain to another. So you've logically created this separate spanning tree domain. Or if you have a layer 2 interface that goes to, say, for example, a third party, like an ISP or something like that, and you don't want them to be able to identify information or glean information about your devices or your topology based on the fact that they're seeing those BPDUs. All right. And incidentally, if you do enable Portfast BPDU filter, in other words, we do that in the global mode, as soon as the Portfast feature is disabled on that interface, the BPDU filter is disabled on the interface as well. However, if you exclusively or explicitly, I keep saying exclusively, I mean explicitly, enable BPDU filter on a physical interface directly, that BPDU filter option is permanently enabled. So you're not only avoiding sending BPDUs, but you're also not accepting BPDUs. Just something to consider. So you're also protecting yourself from somebody injecting information into your topology by sending in rogue BPDUs from from another device. Okay. Now there are some other features that that we talk about. UplinkFast, for example, I can describe what it does. It's not really necessary to configure because UplinkFast is a feature that's enabled automatically as soon as you enable Rapid Spanning Tree. We went through the process yesterday about how we have this kind of cascading or waterfall effect of topology changes and how those topology changes propagate through the spanning tree topology, which not being based on the traditional or the traditional forwarding delays that we see with normal spanning tree. So UplinkFast would be a feature that you would add if you were using 802.1d. It's already enabled if you're using 802.1w or Cisco's variant of 802.1w. I'm not going to demonstrate UplinkFast because it's not necessary, right? If you're going to run MST, multiple spanning tree, which is our next lesson, or if you're going to run UplinkFast, if you're going to run 802.1w or Cisco's version of that, then you don't need to concern yourself with whether or not UplinkFast is enabled because it's enabled automatically. UplinkFast is going to provide essentially very fast convergence using these things called uplink groups in the access layer after you receive some sort of spanning tree topology change. An uplink group is just basically a set of ports. And of course, this is going to be configured per VLAN because spanning tree runs per VLAN. And only one of those ports is going to be forwarding at any given time. So if you can imagine, I've got a group of ports that go up to, that are not Etherchannel ports. We don't have Etherchannel configured on the interfaces. And we have a group of ports that go up to the root, and we want to ensure redundancy, but we also want to ensure fast failover. We can create an uplink group for those particular ports and enable the UplinkFast feature. So the uplink group needs to have at least one root port, which is in the forwarding state, and then a bunch of blocking ports, which are not, the other ports that go towards the root that are blocked for the purposes of avoiding a loop altogether. So other interfaces within that uplink group provide you an alternate path in case for some reason the current path might fail. All right, UplinkFast is really useful in wiring closets that have a limited number of active VLANs, for example, but it's really not something that we have to concern ourselves with too much. All right, so let's say that I had a scenario. Let me walk you through an UplinkFast scenario. I'm not going to do a configuration, but I think it might be useful to kind of take a look at an UplinkFast scenario. So let me get over here to my paint. Where did my paint go? There it is. All right, and let's add to our topology here. So we're going to add a third switch. That's supposed to be a switch, by the way. So we've got switch A, which is, in this case, the root of our topology. We've got switch B, and we've got switch C. All right. Now, given the fact that all these links are potentially fast Ethernet, or they're common links, they all share the same bandwidth, then we know that our topology is probably going to look something like this. This port is blocking, so that's my non-designated port, and this is probably my root port, and that's probably my root port, and then, excuse me, and then these are my designated ports, okay? So if switch C detects a link failure to the current active link, which is this link right here, normally what would happen is we'd have to go through the entire election process, listening, learning. Again, we're talking about 802.1d because UplinkFast is enabled by default in Rapid Spanning Tree. UplinkFast blocks the port on switch C and transitions it to a forwarding state immediately. I'm sorry, I meant to say unblocks the port. So this interface here is going to get unblocked. If I can get my eraser tool here, this interface here is going to get unblocked and it's going to go into a forwarding state immediately. That's the whole concept of UplinkFast. It's really, really simple. In Rapid Spanning Tree, that's done through the different proposals and agreements, and understanding, essentially this would have been, actually, let me ask you guys. We have two designations in Spanning Tree, in Rapid Spanning Tree, alternate and backup. So would this port have been considered as an alternate port or a backup port? Any thoughts?
Alternate port. Alternate.
An alternate port, right? Because it's on the same switch and it's, yeah, go ahead.
No, we were just saying yes, alternate.
Yeah, okay. So the switchover is probably going to take about 1 second to 5 seconds. If it's Rapid Spanning Tree, it'll be even faster than that. So what will happen is after the failure, UplinkFast is going to transition this port directly to a forwarding state. As soon as the switch transitions the alternate port to the forwarding state, the switch then begins transmitting something called dummy multicast frames on that port. Now this is something that doesn't happen necessarily in Rapid Spanning Tree, but again, 802.1d is not as smart and it can't handle these kinds of things as well as Rapid Spanning Tree can. So we start transmitting these dummy multicast frames on the port, one for each entry in what we call the enhanced, what is it called? The enhanced address, ERAL, URL table. It's called an URL table. So that's the enhanced address recognition logic table. That's what it is. Which is essentially the MAC address table, right? Actually, it's more related to Spanning Tree than it is related to the standard data link forwarding table. So that's going to be about 15 dummy multicast frames that get transmitted for every, say, I don't know, maybe 90 milliseconds, 100 milliseconds, or whatever. Each of those dummy multicast frames use the station address in that URL table entry as the source MAC address, and we're sending those to the dummy MAC address of, well, it's a standard MAC address used in Spanning Tree, 01000C, which is Cisco, and then Charlie Delta, Charlie Delta, Charlie Delta. That's a common MAC address that we see in Layer 2. The switches that receive those dummy multicast frames basically update their URL tables entries as well for each source MAC address to use that new port, allowing the switches to begin using the new path immediately. Remember when we talked yesterday about how Rapid Spanning Tree, if a topology change notification is identified, the instructions get processed down the chain to indicate to the switches that they need to clear their MAC address tables for that particular VLAN or all the VLANs if those VLANs are affected by that trunk link, so that we can start relearning the location of individual devices. I didn't really get into a whole lot of detail about why we do that, but it makes sense. Because if I'm learning about a bunch of clients on this interface here, and I've got my MAC address table listed in all those clients, well, if that interface is going to go down, then obviously I'm going to have to identify how to reach those new clients. All right, and that's really the process that we're talking about here. It's a process that allows us to, within really kind of sub-second times, identify where everybody is located. If for some reason connectivity is actually restored on the original root port, the switch waits for a period of about twice the forwarding delay plus an additional 5 seconds before it transitions that port into a forwarding state again. And that's simply because we're trying to avoid the consequences of some sort of flapping interface on that switch. Because it could go down again, it could come up, it could go down. We don't want to keep switching back and forth and repopulating our MAC address table every single time that happens. Okay? So that's UplinkFast. Again, a feature that's automatically enabled if you're running multiple Spanning Tree or if you're running Rapid Spanning Tree. Another feature that's automatically enabled is if you're running BackboneFast. Another feature that's, sorry guys, I'm a little tired today. It's been a long, long week. I taught all day today, CISSP, and I've got to teach all day again tomorrow. So just a little worn out today, but we'll make it through. Okay. So another feature that exists in combination with Rapid Spanning Tree is something called BackboneFast. It's not really necessarily to ensure fast convergence for clients or endpoints. It's more for ensuring fast convergence for the purpose of interconnectivity between the switches, which is why it's called BackboneFast. So what BackboneFast does is it gives us a fast convergence scenario in the network backbone after some sort of topology change notification occurs. Once a switch detects an indirect link failure, in UplinkFast we're talking about direct link failures, but if a switch detects an indirect link failure, maybe say switch C down here, for example, detects that link failed, the switch is going to start receiving inferior BPDUs from its designated bridge on its root port or one of its block ports. All right. What do I mean by that? I described this yesterday when we were talking about the concept of the whole convergence concept. But I even drew the diagram that indicated that we were receiving inferior BPDUs. But what that means is that if this is the root, right? So this link is active, so we're receiving superior BPDUs here. If this link goes down, the very first thing that switch B is going to do is it's going to start advertising itself as the root. And that's what we're deeming as an inferior BPDU, because I already get messages from switch A saying that I'm the root. And that BPDU is much better than whatever I might receive from switch B, because that's the reason switch A became the root in the first place. Okay? So basically, by receiving these inferior BPDUs, I'm getting an indication that the designated bridge lost its connection to the root through that particular link. All right, so that identifies essentially that a single switch has lost its connectivity, and I'm able to identify that there was some sort of topology change. Under normal spanning tree rules, the switch basically ignores those inferior BPDUs. And it'll ignore them for 20 seconds, which is our maximum aging timer in Spanning Tree. We can change that by setting the maximum aging timer, but 20 seconds is pretty adequate. So the switch is going to try to determine if it has an alternate path to the root bridge. If the inferior BPDU arrives on a blocked port, which it would in this case, because normally this port would have been blocked based on our topology, the root port and other blocked ports on the switch become alternate paths to the root. So if the inferior BPDU arrives on the root port, all the blocked ports become the alternate paths to the root bridge. Does that make sense? I'll say that one more time. All right. So if I receive an inferior BPDU on a blocked port, the root port and all the other blocked ports on the switch become alternate paths to the root bridge. So this becomes an alternate path to the root bridge. It doesn't mean it necessarily goes into a blocking state, but it becomes an alternate path to the root bridge. If that inferior BPDU arrives on the root port, pretty much we maintain the status quo. All right. If the inferior BPDU arrives at the root port and there are no blocked ports, the switch assumes that it has lost connectivity completely with the root bridge, and then that will cause the maximum aging time on the root to expire because the root switch is operating according to normal spanning tree operations. All right. Now, let me see if I can kind of walk through a scenario again. We'll use this topology as an example. I don't think I really explained that concept to you guys very well. So let me see if I can kind of break it down a little bit better. Kind of get rid of all these other lines here. All right. So here's an example of our BackboneFast topology. Switch A is the root, of course, again, which connects directly to switch B. In this case, we'll just call this L1 for link 1. and switch C over L2. Actually, we'll make this L2 and L1 since that corresponds to the actual order of the letters as well. All right. The port on switch C that's connected directly to switch B, that's going to go into a blocking state. That's going to be my root port. That's going to be my root port. And these ports here will be designated ports because all the ports on the root are automatically designated. Okay. So let's say L1 fails. All right, that's the scenario that I was going through previously. L1 fails. All right, switch C detects this failure as an indirect failure because it's obviously not connected to that particular link. Switch B no longer has a path to the root because the root port was directly related to L1. So far, so good. BackboneFast, what that does is that allows the blocked port on switch C to immediately move into a forwarding state without waiting for the max age timer. Excuse me, it moves into the listening state, not the forwarding state, without waiting for the maximum age timer or for that particular port to expire. So let's say 20 seconds or so, whatever the max age timer is set to. Default is 20 seconds. All right, BackboneFast then is going to transition the port on switch C into a forwarding state as long as the path from switch B to A, well, this path here doesn't change. The status of that path doesn't change. And if this path moves into forwarding state, now we have a connectivity to go from switch B to switch A. This switchover is not as fast as the name implies, though, right? We're dealing with UplinkFast because we have different interfaces within an uplink group. The switchover takes about 1 to 5 seconds. But when you're dealing with BackboneFast, we're still talking about a 30-second transition period. All right. All right. So if we add a new switch into this topology, BackboneFast is may or may not be activated. It's not enabled by default on the switch, but you can enable it. Also, when we're dealing with shared segments, so like GNS3 where all the interfaces are half duplex, so it recognizes those interfaces as shared connections. BackboneFast does not get enabled on those interfaces either because they are half duplex. Okay? All right. Did I lose my connection? Are you guys still there? To a forwarding state. All right. Does that make sense? All right. The last thing that we're going to talk about before we wrap up for today, because we're getting close to our hour and a half here, is Etherchannel Guard. Now, if you think about Etherchannel, the issues that you can run in with an Etherchannel configuration is that the links that are bonded together could cause unidirectional data flow. Maybe one link is inconsistent in its configuration, so one port might go down, whereas on the other side, the two ports are participating in the ether channel, and all of a sudden you have some kind of loop condition where I'm receiving BPDUs on one side and I'm sending BPDUs, but the other side is not receiving those BPDUs. So it's almost like loop guard in a sense, or UDLD, in a sense that we're trying to identify that there's an issue with the ether channel, which is causing potentially a loop. So it's really a way of finding out if one end of that ether channel is actually not configured correctly. It could be for many reasons, right? It could be that there's some parameters that aren't matching up, or maybe a duplex or speed issue, or it could be that one side is a trunk and the other side isn't. Anything that would essentially cause the ether channel to error disable or whatnot. When there is a misconfiguration found, essentially what's going to happen is the switch is going to place those interfaces into an error disabled state, and you'll get a message. All right? It's a really simple configuration. All you do is just configure the ether channel misconfiguration guard globally, and anytime you have ether channels configured on the switch, then it will make decisions based on that. We can use Etherchannel Guard to detect things like ether channel misconfigurations. between switches. And like I said, a misconfiguration can happen if the switch interfaces are configured in an Ether channel, but the interfaces on the other side are not, right? I could say, for example, go on to switch A or switch 1 here and set up the Ether channel as on, mode on. In fact, let me do that. Let's do port 10 and 11. I'm going to put those into a channel group. So config T, interface range Ethernet 1/0-1, and I'm going to say channel dash group 1 mode on. All right, and interface PO1, switch port trunk encapsulation, .1Q, switch port mode trunk. All right, so if I do a show Ether channel summary, the interfaces are participating in an Ether channel. The port channel's up. It's an operational Ether channel, but I haven't configured the other side as an Ether channel. And because I'm not using a protocol, then it just assumes that these ports need to be an Ether channel. If that makes sense. Okay? So we'll leave that configuration for now. It could be maybe one side you've got 4 ports, for example, and you've only added 3 to an Ether channel and one's not added. There's lots of reasons why the misconfiguration would take place. But let's go ahead and leave that misconfiguration in there and let's see what happens. So let's go into switch 1, config T. It's a little slow right now, I don't know why. Config T. And I'm going to execute the command spanning tree ether channel guard misconfig. All right. Now, if I do a show spanning tree summary, I can see that all of these features that we've been talking about, loop guard and Portfast and BPDU Filter, BPDU Guard, all these features are enabled. All right. Let me actually go into switch 2 and do the same thing. Exit, spanning tree, ether channel, guard misconfig. All right. Now I don't actually have, let me do a show interface trunk. I don't actually have ether channels configured on this switch. Oh, that's interesting. Did I do the right interfaces? 10 and 11, okay. 1011. They're running ISL on this side, but I had the other side configured for .1Q. Let me just make one quick change. It shouldn't really matter. And we can certainly understand why we're not really getting any Ethernet, not fast Ethernet. We can certainly understand why we're not getting any notifications on this side for the Ether channel misconfiguration because I don't have any Ether channels. Let's do switch port trunk encapsulation .1Q and switch port mode trunk. All right. Now I don't know if it's actually going to trigger an event, show interface Ethernet 1/0. Yeah, it still shows connected. So it may be because in this particular case, I'm just using mode on and both ports are, well, you know, it's interesting. I'm thinking about this. Remember, the BPDUs are only going to go over one interface. So I should be sending BPDUs out of one interface and only receiving BPDUs on the other interface. Let's see. I'm trying to think about how I can trigger an event here. Let me try something else. Let me go ahead and here, interface range Ethernet 10-1, channel group 1 mode passive. Interface PO1, switch port trunk encapsulation .1Q, switch port mode trunk. Show Ah, there we go. Oh, that's not it. That's not it. That is indicating to me that I can't form the ether channel because the other side is in mode on and not running spanning tree. I mean, not running LACP. Show ether channel. Oops. Show spanning tree inconsistent ports. Okay, show. We're not seeing the error disable. I may not be able to actually simulate this effectively because... All right, let me try one more thing. Config T, no interface PO1, interface Ethernet 10, channel group 1 mode active. Show run interface PO1, config T, interface PO1, switch port trunk encapsulation.1Q. Switch port mode trunk. So what I'm going to do is I'm going to go ahead and configure LACP on both sides. But if I do a show ether channel summary on this side, what I did in this case is I only included one interface in the ether channel. And in fact, it shows down. And that's because I didn't configure ether channel on the other, or LACP on the other side. So one more thing, no interface PO1. Interface range Ethernet 10-1, channel group 1 mode active. So I'm enabling ether channel on both of these interfaces. Switch port mode trunk, switch port trunk encapsulation.1Q, and switch port mode trunk. Show ether channel summary. Why is it shut down? Interface range Ethernet 10-1, do a shut. Let me just bounce the ports here and see if that fixes the problem. Usually if you're trying to change the ether channel mode, it kind of freaks out if you just do it without bouncing the ports. Show ether channel summary. So we're getting our don't bundle messages, but we're not getting our ether channel misconfig options. What's supposed to be happening is we're supposed to be getting an error disable on the interface saying, hey, this ether channel is misconfigured, and we're going to go ahead and block the ports. But I think what's happening is that the ether channel process is disabling the ether channel prior to ether channel misconfiguration kicking in. I don't usually use ether channel misconfig for that very reason. The ports themselves or ether channel has built-in mechanisms to protect the configuration if there is a misconfiguration, but not sure how I could simulate this otherwise. I think you guys get the idea though. All right. So again, as part of our best practice standards, we want to make sure that we're running some of those Spanning Tree Toolkit mechanisms. Let me see, we have a message here. Does it tell you why it's misconfigured, or it just tells you it is? Mike just says it just error disables. You get a syslog message, much like BPDU Guard, where it says disabling the port because of an ether channel misconfiguration. And it's not even that verbose, but that's all it says. It doesn't tell you why the ether channel is misconfigured. But like you're seeing here, most likely you're going to be able to identify an issue with ether channel before Spanning Tree can even decide that it should do something with that port. So you'll get some inconsistent messages from LACP or PAGP, and then you'll notice that there's an issue with the misconfiguration. Okay, so that's it, guys. There isn't a whole lot else to this discussion, to this topic. I'm going to go ahead and end the recording right now. I had